All right, we are now recording. This is 4025 MAA Mechanics tutorial number 1. Let's start with this first exercise. We have we want to determine the magnitude and the angle measured clockwise from the positive y-axis. So starting from here, measured like that, of the resultant force acting on the bracket, this one, if FB, this force here, is 600 newtons, and theta, this angle here, is 20 degrees. We also know that FA is 700 newtons, and this angle with the vertical is 30 degrees. So let's add these two vectors up, because that's what we want to find. We want to find the resultant force. That means we have to add the two vectors up. Let's go about that. Very simple. Let me draw it first. So this is the center of the bracket, and we have one vector, which is this one, say, that is FA 700 newtons, and it's angled at 30 degrees. And we have another vector, which is FB, so this one, which is 600 newtons. Angled at 20 degrees from this axis, though. Okay. So what is the resultant force? Well, you can do this in the graphical way or in the analytical way. The graphical way is use the, let's say, graphical way, you can use the parallelogram method, where you take the perpendicular to this line. So this is the perpendicular to FA, and this is the perpendicular to FB. So you take the parallel to FA and the parallel to FB, and then you find out that these intersect at a certain point, and this point is exactly the resultant. So this is the tip of the resultant. Come on. No. There you go. So this is the resultant force. Oh, you can see it here. Okay, you can see it now. Or you can use the triangle rule. The triangle rule is just the same thing. So you take this and you move one of these vectors. Let's say, let's move FB on top of FA. Let me this here. Let's move FB on top of FA, and then my resultant is just this one, which is exactly the same. See, it's exactly the same vector I've drawn earlier. See, this and this are exactly the same. You agree with me? Now, this is the graphical method, but of course, this doesn't give you an indication of the magnitude and the angle. We know that it's longer than 600 and it's longer than 700, but it's not, and it's also, so the angle that we want to find is this one. So it's clockwise from the vertical. So this is the angle I want. Okay, this is theta. So that's the vertical. Clockwise, that's the angle I want to find. So let's do this using the analytical method. Analytical method means that we have to split these forces into their components. Now, FA has got an horizontal component along the x-axis, which I have to draw. So this is the x-axis, and this is the y-axis. So FA has got a component FAX along the x-axis and a component FAY along the y-axis. Let me put this here. Okay. And now I'm asking you, how do I find FAX and how do I find FAY? So let's recall the trigonometry. So if you have a triangle like this, and say you know that this is the hypotenuse, you know this angle, let's call it alpha. If this is alpha, we can identify the adjacent edge A. Adjacent means it forms the angle with the hypotenuse. So the hypotenuse and the adjacent edge form the angle that we know. And then, of course, we also have the opposite edge that we can identify. And if this is true, then all these relationships are true. The adjacent edge is the hypotenuse times the cosine of alpha. The opposite edge is the hypotenuse times the sine of alpha. And alpha itself is the arctangent of opposite divided adjacent. These things are things that you should know. These go in your formula sheet. These are already in your formula sheet, but please remember these. This is basic trigonometry. Now look at this. This is also a triangle. This triangle has got a 90 degrees angle. This triangle has got a 90 degrees angle. So we can also use trigonometry here to find what is the adjacent or opposite edge. Well, now, what's the angle that we know? Do we know this angle or do we know this angle? Because this is 90 degrees. So now what we need is one of the two angles, and then we can apply these. So help me out. What is the angle that we know? We know that this is 30 degrees. So does it mean that is this 30 degrees or is this 30 degrees? So the bottom or the top? Come on, chat. Shadab says top. Okay, okay, you're all saying top. That's very good. Okay, so you know that this bottom one is 60 degrees. So that means this must be 30 degrees. So this is the angle that we know. Very good. And so based on this, let me report this triangle here. On here. Let me delete this one. And let me take this here. Let me take this here. Okay, now help me out. How much is FAX based on this? Based on these three formulae, how do I find FAX? How do I find the horizontal component of FA? I must do the hypotenuse. So first of all, FAX, is it opposite or adjacent? Is this opposite or adjacent to 30 degrees? That's opposite, correct, Shadab? So that means we have to use this one. So opposite, FAX equals hypotenuse, FA times the sine of 30 degrees. There you go. We get here. And we say that FAX So this is FA split into components. We have FAX is FA times the sine of 30 degrees. Put this a bit down. So in numbers, FA was 700 newtons. So this is 700 times the sine of 30, which gives, let me see if I can open the calculator. So 700 times, see my calculator is in degrees. You can see it here, deg. So 700 times 30 sine, which is 0.5. Of course, the sine of 30 degrees is 0.2. That gives 350 newtons. See, I am using the units. I'm putting the units at the end of my calculations, not using units inside the calculations. After I get to the end of it, I stick a unit there. So now help me out. What is FAY? What is the vertical component of FA? Let's look again at this triangle. Now, of course, it's not opposite anymore. It's the adjacent. So what do we use? Cosine, correct. So we use the cosine, and it's FA, the hypotenuse, times the cosine of the angle. In numbers, we have 700 cosine of 30. Let's put the calculator on again. So sorry, I'm just so 700 times 30 cosine. There you go, 606.2. Okay, so we've done this. So we have split this into X and Y. Now we need to split this into X and Y. Of course, this one was pulling upward and rightward. So the horizontal component was rightward and the vertical component was upward. Whereas this one is pulling upward and leftward. So I am expecting that the horizontal component will be leftward and the vertical component will be upward as well. You agree with me? Good. So let's copy this one. Put it here. And help me out figuring out what is FBX and what is FBY. So FBX is sine or cosine? Cosine. So FBX is adjacent to 20 degrees angle, adjacent. So that means we are using the hypotenuse times the cosine of 20 degrees this time because it's 20 degrees. And this gives 600 cosine of 20, which is equal to 600 times 20 cosine, 563.8. Newtons. Therefore, FBY, of course, if this is cosine, the other one must be sine. So FB sine of 20 gives 600 sine of 20, which gives, again, 600 times 20 sine, 205.2. Newtons. Now we have split both forces into components. Now what do? We want to find the resultant. Well, the resultant is, help me out, how do you find the resultant? So the components of the resultant are Rx and Ry. And how do we find them? Well, Rx is the sum of the X components and Ry is the sum of the Y components. So this is the sum of Fx and this is the sum of y. Now let's start with the y1. No, sorry, let's start with the x1. We have 350 and 563.8. So do I sum them or do I subtract them? Have a look. Do I sum them or do I subtract them? Subtract. Okay, subtract means one of them is negative. Which one is negative? FA or FB? So FAX or FBX? You're saying FBX. I do agree because look, FAX is agreeing with my x-axis. My x-axis is positive rightwards. So FAX is pulling rightwards. So this is positive FAX and negative FBX. Okay. So the calculation I must do is FAX minus FBX. So this gives 350. Well, let's not do all, let's not write all the calculations. 350 minus 563.8. It's minus 213.8. What does it mean for a force to be negative? What is a negative force? What am I stating here? Rx is minus 213.8. I am saying that the resultant force is pulling leftward. See, I've done this graphically already, and I know that the resultant force between these two is pulling leftward. This has got a leftward component, which is only 200, and an upward component, which I'm expecting to be much larger. Okay. So this is going in this direction here. So do we sum or subtract the y components? So FBY and FAY. Do we sum them or subtract them? We do sum them because they go in the same direction and they go in the same positive direction because the y-axis is going up. Okay. So FAY plus FBY equals 606.2 plus 205.2 is 811.4. And so newtons. So this means that this one is going up. So my resultant force is pulling left and up. Did I answer the question? What was the question? Magnitude and angle. Did I get the magnitude of the force? No. How do I find the magnitude of the force? Now, this is the Cartesian representation. These are the components of the force. Can I find? So this is the force I was saying. So this is the resultant, which I said is pulling leftward and upward. And so we have one component here and one component here. And as we said, small component and large component. This is 200 and this is 4 times as much. So this is about correct. So this is R. This is Rx and this is Ry. So how do I find R? Come on. How do I find R? Pythagoras theorem. Correct. So let's do R. So from Cartesian Rx, Ry to polar R at angle. let's call it beta. So let's use Pythagoras theorem to find r itself, which is the square root of rx squared plus ry squared. Sorry, horrible writing. Squared plus ry squared. And this is equal to 213.8 squared. I'm not bothering using the negative because you know that squared is the same thing, plus 811.4 squared. This gives this number, under square root is 839.1 newtons. So this is the magnitude. And this is one of the answers that we wanted. How do I find the angle? Sorry, I called it beta. Well, beta is this one. Well, we want to find this angle here. But this angle here is 270 degrees. It's 270 degrees plus this. Okay, so let me spell it for you. The angle that we want is 270 degrees plus this. Do you agree? So this is 270, and this is beta. So let's find beta, which is this angle here. How do I find that? Look at this. The angle is the arctangent of opposite divided adjacent. So the opposite is ry, adjacent is rx. So that means that this is the arctangent of ry divided rx, opposite divided adjacent. So if I do ry 811.4 divided by rx 213.8, and I take the arctangent of this, make sure this is in degrees, this is 75.2 degrees. This is the angle. And this is the angle from the negative x-axis. Okay, so this is the negative x-axis. This beta is the angle from minus x. So if I add plus 270 degrees, which I said it's this one, so this is the angle from the negative x-axis, then in order to find this one, I have to add 270 degrees. If I add plus 270 degrees, I get 75.2 plus 270, 345.2. Angle from y, which is what the question was asking. Okay, any questions? Was it fine? Was it easy? Come on, any comment? How is it so far? Bearable? Good? It was easy. Good. Right. So we can now tackle this one. And then we'll do this one. And that's it. We're done. So now, well, here for the first question, I went through every single step. Now, I won't bother with numbers a lot. So you'll do the calculations for me. I'll just put the equations on. So let's do question 2. Now this was question 1. Let's do question 2. Next to green. Leave it. Now, question 2 says, determine the magnitude of this force Fa and the direction theta so that the resultant force is completely along the x-axis and has a magnitude of 1250. Okay, so now it looks like it's the inverse problem. First, in this question here, we knew the two forces. We wanted to find the resultant. In this question here, we know one force and the resultant, and we want to find what is this force that makes it so the resultant is this large and in this direction, completely along x. So let me draw this on a paper. So this is what we know. This is the center. We know this force is 800 newtons at 30 degrees. And this force is, who knows, this is what we don't know. And we don't know the angle either. But we do know that the sum of these two must make this one, which is the resultant, which is 1250 newtons, and is completely along the x-axis. So this is the x-axis. This is the y-axis. There you go. So this one is 800 newtons, FB. And this is 30 degrees. And this one is completely unknown. So let's call this FA at an angle theta. See, we want to find this angle theta from the vertical again. Okay, what do? We do exactly the same thing. So we have to split FB into components. The components of FB are, of course, let's say this one and this one. This is FBY. This is FBX. And as you can see, FBX is positive and FBY is negative. And then, well, we don't split FA because we don't know it, but we can still call it FAX, the horizontal component, and FAY, the vertical component. So split FBX. How do I find FBX? Come on, help me out. What's the angle that we know? What's the angle that we don't know? So first of all, which one is the angle that we know? Is it this one? Oh, sorry, is it this one or this one? Top or bottom? Bottom. That's correct. So we know that this is 30 degrees. Okay. No, it's not top, Jesse, because we know that the top one, the top should be 60 because 60 and 30 must make 90 degrees. See? This is a 90 degrees angle. Part of it is 30. So the rest of it must be 60. So that means this other one must be 30 degrees. Is it clear? Yes, good. So help me out. How do I find FBX? FBX is FB times sine or cosine? Opposite or adjacent? Sine or cosine? What do you think? Okay, you're all saying cosine. That's correct because FBX is adjacent to the angle. So cosine of 30 degrees. And now you help me out. You do this calculation. How much is 800 times cosine of 30 degrees? I'll start it anyway. 800 times cosine of 30 degrees. 692.8. And FBY is, of course, FB sine of 30 degrees, which is 400 newtons, because I told you earlier that the sine of 30 degrees is 0.5. So 700 divided by 2 is 350. So 800 divided by 2 is 400. All right. So now we don't do anything with FA because that's it, but we know that the resultant Rx and Ry. How much is the horizontal component of the resultant? Write it down in the chat. So what's the horizontal component of the resultant? Do we know it or not? Yes, we do know it. It says here, 1250 newtons. And what's the vertical component of the resultant? Well, this is completely horizontal. So that means it's got no vertical components. In fact, the resultant only pulls rightward. It doesn't pull upward nor downward. So this is 1250 and this is 0. But we also know that this is also FAX plus FBX. And this is also FAY plus FBY. See what I'm doing here? This is an equation. This is an equation. And we have one unknown and two unknowns. Because FBX is a number, FBY is a number. So we have two equations in two unknowns. So we can solve this. In fact, I can say that solving this, I get FAX equals 1250 minus FBX, which is equal to 1250 minus FBX, 692.8, 557.2. And let's put this in green because this is what we found. And this is newtons. And solving this one, these are two single equations in one unknown. Okay, so you don't need to put to solve them simultaneously because each unknown appears in a single equation. FAY equals 0 minus FBY, which is equal to minus 400, of course. So we are saying that FAX is pulling rightward. Do I? No, sorry, it's my mistake here. This is minus 4. My mistake is not here, my mistake is here. Because this is minus FBY, because FBY is going downwards. You didn't tell me. Pay attention, please, because I'm very prone to make silly mistakes. So the correct equation is this one, because FAY is going up, because FA is pulling up, but FBY is going down, because FB is pulling down. Okay, so this is it. So 0. FAY is plus FBY then. So this plus FBY. So this is plus 400 newtons. So this is going upward. Okay. Now this doesn't answer the question yet because it's asking for FA and the angle. So let's check these are the two components of FA. This is FAX and this is FAY. And let me take this out here. Make it a bit smaller. And let me clear this one, this one, this one, oops, this one. There you go. So how do I find FA? Well, the square root of FAX squared plus FAY squared equals, remember, Pythagoras theorem. So 557.2 squared plus 400 squared equals under square root 685.9. And how do I find this angle theta? Come on, what's opposite, what's adjacent? So this is arctangent of what? Arctangent of Come on, chat. Come on, chat. Fay over Fax or the other way around. So Shadab says Fay over Fax. Do you agree? Kelechi says other way. So we have two schools of thoughts, but only one is correct. So what's the formula? Let's go back to the formula. The formula says opposite over adjacent. So what is opposite to theta? Look here. Opposite is Fax. So Kelechi is correct. Is Fax over Fay. And this gives 557.2 divided by 400. And arctangent of this, make sure this is in degrees. Okay, arctangent is 54.32 degrees. So these are the answers we are looking for. Oh, I left the units out here. Oh, my bad, newtons. There you go. Okay, how is this? Again, very easy. Let's check 686 newtons. Yes. 54.3. Yes. All right. All right. Let's do this one. Now, this one has got three forces. Again, I also suggest you solve this same exercise with the graphical method. With the graphical method means find what's the vector. So this is the vector that is required to, because the sum of this plus this must give me this. This is a very easy graphical method calculation. Okay. All right, so let's do question 3, and that's it. Let's call it a day. Guys, I want a bit more participation if possible. I know it's the first week, so we still have to get used to each other.
The question 1,
yes.
The angle, isn't it in counterclockwise?
In question 1, the angle is?
Yeah.
What do you mean?
The angle, it should be in counterclockwise, right?
No, well, that's up to you. In question 1, it explicitly asks for, oh, measure counterclockwise. Oh, that's why. Sorry, my fault. I thought it said clockwise. So in that case, you want to find this angle here. So let's call this gamma. Well, but that's easy. You do 360 minus what we found. One is what we find here to find the angle gamma, which is 14.8. It makes sense. See, 14.8 plus 345.2, it's 360. So see, it's the same thing. I know this is my fault. I should have read the question better. I thought that he was asking for the clockwise angle from the y-axis. Okay, thank you. Thank you very much for pointing this out.
Hello, sorry to interrupt.
Yeah.
So how did you got Ry is equal to Fay minus Fby? And
so you know that the resultant force is the sum of the two components.
So how did you got Fay positive 400 newtons?
Because look at Fay. Fay is along the y-axis.
Okay.
Fby is opposite to the y-axis.
Yeah.
Instead, for the first equation, Rx, Fax is rightward, Fbx is also rightward, and the x-axis is also rightward. So this is a sum. This is a subtraction. This is positive. This is negative. Okay.
Okay. Thank you.
Good. So let's do this last one. I think it'll probably take the last 15 minutes of this tutorial. And if F1 is 600 newtons and phi is 30 degrees, determine the magnitude of the resultant force and its direction is, oh, see, this is clockwise now from the positive x-axis. All right, so let's draw this. This is the point where all the forces meet. And we have one F1, which is 600 at 30 degrees. So let's say this one. Then we have F2. Let's make it green, which is 500 at 60 degrees. So let's say this one, 600, so longer than this at 50 degrees. So this is 500. This is F2. This is F1. And this is 600. And the last one, let's make it, I don't know, orange. Yeah, let's make it orange. That's 450 newtons. That is sitting on a 3, 4, 5 triangle. So this is the smallest of the three because it's only 450 newtons. And we know that it sits on a 3, 4, 5 triangle. Now, what does that mean? Remember what I told you about the 3, 4, 5 triangles, where this side is 5, this side is 4, this side is 3. Okay, so let's solve this one. We want to find the resultant force, which I don't know, since it says measured clockwise from the positive x-axis, should be probably, so this is the x-axis, this is the y-axis. Let me clear this one. Okay. The resultant force, let's say it's this one. It's probably 600 is here, 500 is here, 550 is here. It's probably like this. Come on. Come on. Okay. Which I don't know yet. Okay, so I'll adjust it because I have no idea, but possibly like that. So this is my resultant. And so we have to split now. So let's draw the triangles. This is 600. And so this has, let me put the angles as well. So this angle is 30 degrees. This angle is 60 degrees. And this one is a 3, 4, 5 triangle. So let's start with this. Start with F1. The components of F1 are F1x and F1y. Come on. So this is F1x and this is F1y because the x-axis is horizontal and the y-axis is vertical. This is the angle that we know, 30 degrees. So help me out. F1x is F1 times sine or cosine? F1x cosine of 30. That's equal to 600 times the cosine of 30, 519.6 newtons. And F1y is, of course, sine of 30. That's just 300 newtons. Okay, so F1 is done. Let's do F2. So let me copy this one. So this is the first component. This is the vertical component. This is f2x, this is f2y. And this is 60 degrees, as I was saying. So what do we use for f2x? Sine or cosine? Cosine. So f2 cosine of 60 equals. Now, if the sine of 30 is 1/2, the cosine of 60 is also 1/2. So this is very easily 250. Let me triple check. So 30 cosine, sorry, 60 cosine, 0.5, same, so 250 newtons. And this is f2 sine of 60, which is 500 times 60 cosine, sorry, sine, 500 times 60 sine, 433. And now let's do f3. Now f3 is a bit complicated. Well, it's not complicated. Come on, no complications. It's just, no, sorry, not this. No complications. It's just you have to think about it a bit. So here we know that this angle here, let's call this alpha. Let's call this angle beta. What I'm saying is that this is on the hypotenuse of the 3, 4, 5 triangle. That means that alpha is arctangent of opposite divided adjacent. So it's arctangent of 3/4. And beta is arctangent of 4/3. So once you know these, you also know that this is also, because these are similar triangles. Did you do similar triangles at school, or college, or sixth form? So this is, first of all, this is f3. This is f3y. This is f3x. And this is also alpha. And this is also beta. Okay, so that's the idea. I'm giving you the edges of the smaller triangle, but since this is a similar triangle to this larger triangle, once you find alpha and beta, you can also use alpha and beta here. You don't need both, you only need one. Or you can also say that since you know that 4, that's another way of doing this, is 4 is hypotenuse. Let's take alpha as the angle that we know. So 4 is the hypotenuse times the cosine of alpha. And 3 is the hypotenuse times the sine of alpha. So here we can say that the cosine of alpha is 4/5 and the sine of alpha is 3/5. So we can, so instead of sine of alpha and cosine of alpha, we can now use these two. Okay, so let me put this down here. And so I'm going to say that f3x, f3y. So f3x is the hypotenuse times, let's use alpha. It's the hypotenuse times the cosine of alpha. Sorry, f3x is this one. So it's the hypotenuse times the sine of alpha. But the sine of alpha is 3/5. So f3x is 3/5 of f3. And f3y is 4/5 or F3. See? Or you can just find alpha and then use the cosine of alpha and sine of alpha. It's exactly the same thing. So you try both methods, see which one you like the most, and then you stick to that one. So F3 was 450 times 3/5 is 270 newtons. And 450 times 4/5, it's 360 Newton. Okay, yes, thank you. I don't see your name. I only see your email address for some reason. Okay, so the only thing that's left now is, of course, the resultant. So the resultant is the sum of the forces along x, and the resultant y is the sum of the forces along y. So this is f1x plus f2x plus f3x. Is it all positive or not? The x components are all positive or not? Let's look at the triangles. Are the x components all positive? Not all. So which one is negative? F1, F2, or F3? Oh, correct. F3 is not positive. So the equation is not this one. It's actually this one. All right. And so let's do this. This is 519.6 plus 250 minus 270. That's 499.6 newtons. What about the vertical components? Are those all positive? So what's the equation? F1y plus or minus F2y F1y goes up, see? F1y goes up. F2y goes down. F3y goes down. Yeah, so the equation is F1y minus F2y minus F3y. So let's make that. This one is F1y is 300 minus, no, sorry, I fault, 300 minus 433 minus 360 minus 493. So we are saying that this is going in this direction and downwards. So this is the resultant. And as I was saying, see this direction, so rightwards and downwards. That's my resultant. And look, it looks they're almost the same number. So it's almost pulling with the same intensity rightwards and downwards. So this angle here, which is what I want to find, let's call this gamma. This angle here is almost 45 degrees. How do I check that this angle is almost 45 degrees? How do I find this angle gamma? Again, opposite divided adjacent. What is opposite? What is adjacent here? Rx, or this is Ry. This is Rx. So how do you find gamma? Arctangent of Rx over Ry or Ry over Rx? Yeah, no, yeah. Ry over Rx, yes. So Ry over Rx. That's correct. So let's do this. It's 493 divided by 499.6. It's almost 1. For the arctangent is 44.6 degrees. Okay, almost 45 as we stated. And what is the actual resultant? That's the square root of Rx squared plus Ry squared. That's equal to 499.6 squared plus 493 squared under square root 701.89. 701.9 newtons. These are the two answers that we were looking for. Let me check if this is correct. 702, yeah, 44.6, correct. All right, any questions? No questions? I'm going to tidy this up a bit while you tell me, you ask me some questions if needed. No questions at all? Was it all easy? Did you understand everything? So one takeout. Now let me rewrite this, which is horrible. This is gamma arctangent of Ry over Rx equals 44.6 degrees. This is R square root of Rx squared plus Ry squared, which is equals 71. Let's get rid of this. So no questions apparently. So I'm going to upload this onto Aula as well as the recording as soon as it's ready. All the Aula pages. So even if you are from a previous cohort, you'll also see this one. Thank you very much for attending the tutorial. If you don't have any more, do you have any other recommendations for use to exercise in our time? Oh, there's the book. If you go on Aula, I told you here, not this one, this one. So if you click here, you go to the reference book, which you need to log in using Coventry University. And of course, log in as well with your account. So you'll see this is the course book. And I told you, look at example 7.3 and example 7.4. Now, if you go at chapter 7, which is force vectors, this is exactly what we did in class. So there's the lecture, parallelogram laws, subtraction, multiplication, whatever. But you also find examples and more exercises. Can I access this book if I don't have a Coventry email yet? I'm afraid not, because you need the Coventry University email. So this is the example we did in class, remember? 7.1, 7.2. So there's all these examples, and these are problems. So these are all the problems. These are basic problems, fundamental problems. And then you have the actual problems, which are a bit more difficult, that require more thinking around. Okay, it's also very, very good examples. Okay. All right. Thank you very much, guys. I will see you next Monday. Yes, next Monday is the lecture. And if you're just attending the tutorial, I will see you next week on Wednesday. But remember, on Wednesday, from now on, we will be having the session right after Katerina's fluid mechanics, thermofluids tutorial. Okay, so the tutorial will be 2 to 3. So on Wednesday, Katerina will give you the thermofluids tutorial 1 to 2. Right after that, you go out of her link and you get into my link, and we solve the tutorial for the week. All right. Okay, thank you very much, all of you. I'll stop recording right now. Stop recording.